Let's play a little game. I want you to stand up and run around whatever room you're in twice, and then engage in a little thumb work with yourself or someone nearby. Now, how long do you feel like that is? Do you feel like it would be longer if you had to squat the whole time, or if you had to boringly sit and stare at us? Well, we're trying to answer those questions by asking, does time fly when you're having fun?
So to answer this question, we need to do a little background research for our hypothesis. We made the research on two big variables. The first one being how they're feeling, and if the person is having fun or if they're bored. And the second variable was age, which was less of a focus in this experiment, but was still present. So the first thing we found for age was that when people are younger, time seems to go a lot slower because there's a lot of newer experiences that they focus on every little aspect of, rather than just living the moment where we were and focus on every single thing. When people are older, they have done these things thousands of times throughout their life. So it's more muscle memory and not focusing on every aspect of their learning. When people are having fun, time seems to fly, and we've all experienced this at that point. This is because we're not focusing on everything around us, kind of like older people when they're last talked about. We're not focusing on every single aspect, and we're just living in the moment and enjoying themselves. When people are bored, they look around at every detail and they try to pull entertainment out of anything that they can. And this makes time really slow down, even though it can be the same amount of time as somebody having fun.
So now we've formed our hypothesis, and to understand it, we can sum it up in one sentence. The happier events correlate with faster time. So as Forrest just said, as people perceive events that are more enjoyable, time speeds up because they focus on the big picture. They don't have to pay attention to major little details that may be crucial for survival or something else like that. As opposed to that, when somebody's in a stressful or even dangerous situation, they're going to focus on each individual detail in that situation to ensure that they're safe, protected, or somebody else. This is just a more in-depth version of that. The more fun a person is having, the less amount of time they think is passing. And why is this? They're not focusing on every aspect of what is entire time. Instead, they're focusing on the big picture.
Now, how do we test our hypothesis? Well, first we need to identify who we're going to test. According to our background research, there are theories that state and explain why, as we age, time feels a little bit faster. So I'm going to separate the participants into age groups. These age groups are 7 to 12, 13 to 18, and then 19 plus. But as you can see, there's no group for under the age of 7. This is because a developmental study explained that those under 7 cannot perceive time correctly because they can't count and they don't see time as a constant number. So we excluded them out of our data set in order to get rid of any other varying states. Now, next is to determine what the participants are going to see. We decided on 3 videos. Our first video was a control. It was a white blank background. Our second video was a happy video, and it was about animals doing something a little bit goofy. Now, our third video was a sad video, and it showed an animated seal being coached. Now, while we were showing all of these videos, each video was 38 seconds long, and we didn't show the time bar at the bottom so the viewers could guess how long the video was. Therefore, we can rule out any external factors. Now, what are the results? Well, we have 55 results, or 55 participants, and we found some very distinct trends. Our first trend was the control. So, as you can see from the graph, each dot represents a participant. Those in yellow are between 7 to 12, those in blue are between 13 to 18, and then those in red are 19 plus. As you can see, the majority of the dots are underneath the x-axis, and since our y-axis is time difference, we can see that the majority of the participants underestimated the 38 seconds. This contrasted with our expectations because we thought that as people got older, they would be more underneath the x-axis, and as people got younger, they would be higher above the x-axis, and therefore create a higher rate. But as you can see, this is not the case.
Yeah, so looking at our other two data groups, we had happiness and sadness, and actually this is a little surprising because contrary to what our hypothesis said, the control difference was actually the difference was lower as people aged, whereas in happiness and sadness, people actually guessed longer as people aged. So the blue line represents the best line of fit for the 15 to 14-year-old age group, while the red represents 19 plus. And so here you can see that as people age older on the happiness video, that the time difference is increasing, and that was different from what we originally thought it was going to be. But we can't really draw any conclusions from this because there's a lot of data that we're missing. For example, you can see that between about 15 years old and 30, we have basically no data except for maybe a 29-year-old. So we need to fill in that role in the future. And then we also have an issue with that we have so many people in the 15-year-old group, but only one 12-year-old. So what is control hard numbers? So for the control, we had a mean of negative 6.89, which means that most people on average guessed around 6 seconds off below what the original timing, which was 38 seconds in the video. And the median was negative 12. And for happiness, we had 15 seconds for the average, and a median of 7. Sadness, we had a median of 1.29, and a median of negative 4. And the reason why we also split the median here, not just the average, because the median is not liable to the outliers. And there's a few people who actually guessed super high or super low. One person guessed 150 seconds compared to the original video, which is 38 seconds. So that could have swayed the average quite a bit.
So these results were not what we expected at all. So we expected time to find and having fun from our background research. But the happiness one, we can see they mainly guessed that the time was longer than it actually was, meaning they weren't having fun, or our hypothesis was wrong. The same thing happens with the other ones. We consider data is just a little bit off of what we expected, such as the control, which the mean is negative 6, which we expected it to be a lot higher than 38 seconds, because we were on the time forward. But instead, that's where we get into our errors. The second thing was wrong anticipation. So if we're going to change this experiment in the future to make it more accurate, the first thing we need to change is the control. So our control video was just a white screen that was supposed to make the viewer very blurry. But unfortunately, a lot of the participants expected a jump scare for something to pop out, and were waiting for something to happen that was never actually going to come. And because of this anticipation, we could skew our results because we think maybe their heart was racing, and they were not focusing on the detail of them because they were always waiting for something to happen.
There are a few other factors that limited our data and what we could derive from it. For example, we could have chosen something better for the fun category. I noticed a lot of people weren't really laughing or were very engaged in the video because it was just a bunch of animals just goofing around. To be honest, I don't think it was that entertaining, just having a dog run around the field. So we could have done something better in that category. Maybe done a video game, could have done something along those lines, or we could have had them be engaged in something that's fun. Could have just chose something different. Another thing is the sadness video. Surprisingly, we actually had one participant who was laughing the entire time during the sadness video, which is not what we wanted. We wanted them to be sad and grieving. That was not the case. So maybe there's something different for that category. And then also, we just need more data. We were really lacking, like I said earlier, between the 20-year-olds and 30-year-olds. So we should have had more data there if we had more time and more resources. So over the summer, what we would have done is probably had a different type of video or different engagement, and then we would have recorded data for a much wider range of age groups and recorded more data.
So, in conclusion, one of the biggest bricks thrown in our plans was definitely anticipation. Anticipation caused every participant to anticipate something was going to happen. Either something malicious like a jump scare, something unexpected, anything along those lines. We also could have had something more inclusive for our fun video. As was said before, the fun video was not very engaging and it was hard to follow. And honestly, this led me to believe that fun is subjective, like very subjective, more subjective than I would expect. At least in this experiment, that was what was reflected. So the next time, we'll focus on those three things.